G'day, and welcome to my session where today I'll be talking about how I reduced my actual Power BI dataset by a whopping 60%. I hope you'll find this interesting, and I have reused this actually quite a few times in multiple places. So let's get started. Cool. First, I know this is typically at the end, but I'd like to say a special thanks to the sponsors and for the data platform geeks and the SQL Server geeks for putting this together. They provide a great content for the community and for others, and a special thanks to Microsoft for sponsoring this event. Without this, they wouldn't be able to put forward and watching my session and other great sessions that you can see. We would also like you to complete the session evaluations. I'll put this up again at the end of the presentation, and no doubt it will be part of the chat window when you're busy viewing and watching this video. Another thing I guess I'd just like to highlight is I'm going to save all the questions to the end. This will just allow me to get through the content, and then I can answer any questions you have or any ideas or things that you would like to go through with regards to this. Okay, so let's start off with a little bit about me. I am a data analytics consultant. I work for myself at a consulting company called 4Mu. I'm based out of the Gold Coast in Australia. I'm a co-organizer of the Queensland Power BI user group. So one day when you're allowed to travel again, if you're ever in the Queensland, Brisbane area, please look us up. We're great to have you there. I'm an existing Microsoft MVP. You can find me on Twitter at Gilbert Q, and I have a blog, 4mu.com/blog. Now, just for a bit of fun, before we get started, there's a picture of me on the right hand side, and what I like to be known as, or in terms of having that on, is called a mammal. So a mammal is a middle-aged man in Lycra who goes around riding bicycles to keep fit and spending time with others. So I hope you enjoyed that. Okay, so let's get into what we're going to present today. What I'm going to present today. So today I'm going to be presenting real-world optimization techniques and how got about and work through all of this in terms of getting the actual data set a lot smaller, best practice recommendations, what you should do, especially when you're using bigger models or you're looking to reduce the size of your models, how data types affect the size of your data set. So while there's lots of different data types, using different data types and how VerdiPack uses those affects the size of your data set. And then a real world implementation where I put all these steps together and actually did this for one of my customers. And what I like to preface with is, when data sets are small and there's not too much going on, you can get away with a lot. You can get away with, not really looking at data types and all these kind of things. But as your data set grows, you want to start looking at the size of your data set, because the smaller you can make your data set, the faster the things can actually run, which is what is key to getting it all up and running and getting it all working. Moving on to there, so the goal is to make the data set as small as possible. This can be achieved with the star schema, and also the analysis service engine is actually designed to do this for you. So I'll go into details what I mean by the star schema and the analysis service engine, and how it actually goes about putting these all together for you. So smaller is always better when coming to designing models. The smaller we can make it, the less memory it consumes. The less memory it consumes, the quicker it can compute. So a few things with regards to making things smaller is, remove columns that have high distinct values, or fields with high cardinality is what they like to say, as well as removing fields in your data set that do not have columns that you don't need. So that straight away very often can just shrink the size of your data model. An example is like a row ID on a database table field that's got no actual value. There's no keys associated to that. So just not having that in, you will save a massive amount of space, because every ID in the row is going to be unique across your data set. And when you're talking in hundreds of millions of rows, that starts to make a big difference. Another thing to make things smaller is do as much as you can, as I'm sure you must have heard before, from as close as possible to the source in terms of querying the data and getting it in. Sometimes this is not possible, and that's fine if it's not possible, but ideally do everything then you can in Power Query. Power Query is extremely powerful. You can do a lot of shaping and a lot of manipulation in your data set to do that. And the reason for that is when the compression starts to work, it does a lot better compression from Power Query into Power BI versus if you have to create a calculated column in DAX. While there is still some compression, it doesn't get the same level of compression and analysis that it does when you're bringing it from with the Power Query into the model. So ideally, again, do as much as you can at the source or in Power Query, and just use DAX for creating measures ideally. If possible, join multiple tables to create one single table. And the example I like to use is very often you can have a products table with a product subcategory and the product. Those sometimes can be 3 separate tables, and it's not necessarily an issue, but if you want to create hierarchies and that kind of thing, those 3 tables very often can be all brought together as a single products table. That allows for you to create a hierarchy, and what that then means is having that single table, you have a lot. It's just one single table, so there's 3 tables where there's lots of repeat values, additional relationships, etc. So those are some of the techniques I use, where I used to say, okay, how can I make this data set smaller just with some fundamental best practice principles. Then moving on from there is the star schema. And what the star schema is almost, if I had to represent each touch point at the end of the star, is a dimension, and then the central part is your fact table. And what that allows you to do is by having the star schema, it just makes things a lot more efficient, as well as the Power BI engine, the VertiPack engine, is actually designed to run really efficiently using the star schema principle. And I'll show you in a couple of slides what I mean by that. Another thing I see quite often is you sometimes have a table with multiple values as shown on the screen. So the date and time is almost unique, but the user, the source, all those other columns, they're actually repeated again and again. Now while the VertiPack engine is very good at compression, it still has to store a lot of this data. So even though it's storing just a bit of each data, it still has to store it so that when you want to use it, you can see all of these details. And this is where often I've seen over the years people saying, oh, can I not have, why do I need dimensions and facts? Why can't I have it in one big single table, almost as the example seen on the screen? And while that certainly is possible, A, it takes up more space for it, and then B, it's not the engine's not designed for that, and C, if you have to make a change to a table that should just have a few values, and your data sets, for instance, say 10 million rows, now you've got to update 10 million rows, versus if it's a dimension table that's got 6 values and you want to add a 7th, you just add the 7th row and refresh the data set and you're done. You've actually only added 1 row versus you haven't actually added or had to update 10 million rows. So in this example here, we could take these multiple values where we're looking particularly at the operation, which is the single column represented, and now I can take that single column and just have it represented as shown here, 1 row per each operation. And typically, again, if you've got best practice, you can create keys. If you don't have keys, you could still just join them via the actual names, but you got to be a little bit careful because it's got to store the space in that. And again, smaller data sets, it's okay. Larger data sets, it makes. And again, this helps with the compression, gets things nice and small, and an easy way for users to also find that information. So moving on from there is how does the star schema work in the actual analysis services engine? So in this example I have over here, based now where I've actually got my operation dimension joined to my fact table, where it's using a one-to-many relationship. And this data set is just the Power BI audit log, as you can see. And so what actually happens is when you write a DAX measure, and there's a typically using calculate, so the calculate's got to filter something. What it actually does is it first goes to the dimension table and filters on the criteria. So if I said filter where operation equals view report, what it'll do is it'll actually first go to the operation dimension, find the row that equals view report, and then we'll traverse the relationship and find those corresponding rows in the fact table. So what that means is it's very quick to look up that row in a small dimension table, say that's got 7 to 10 rows, but now it already knows what information it's looking for when it starts to go into the fact table. So instead of it going and scanning the entire fact table and trying to find out where the operation equals view report, it now can go and just find a subset of it. And that's what makes the analysis engine really fast and getting this all going. So these are some of the concepts that we put into place and look at to actually get it working, and how it all works, how it runs so fast. But these are also the things that I look at and go, okay, you got to start with getting a lot of the best practice things working, and then in my example I was like, okay, I've got the best practice, the data set still feels too big. How can I now make this data set even smaller than that? So how did I do that? So what I did is, as in this example, obviously I love Power BI. I've used a Power BI report to show what I've done, and in this example I'm going to show you the data as it was or as it is, where it's just coming in, what it looks like using DAX Studio, and just to show you, okay, this is what it looks like, and go through the process of how I actually went through and said, oh, is there a way to make this smaller? How can I make this smaller? Those kind of things. And then what I'll do, almost alluding to what I'm going to show you, is showing you the data as is, where I've changed the data type to a fixed decimal number, and then where I've changed it to a whole number. And as you can see, from where I started to where I ended, in this example, I got a 65% saving. Now, as with anything, my favorite answer in Power BI is it depends. It always depends on your data, the distribution, a whole factor of different things. But I've seen this happen fairly constantly across different data sets if you have this particular scenario that it fits. So one of my last slides, I'm not going to show any more after this. We're actually going to jump into the demo. But what I'm going to show you is, again, the start with one integer column where it's changed to a whole number, and then we'll change to the decimal, and then change to the whole number. Okay, so if we had to step out of that, what I'm going to do is, here is my Power BI desktop with a great new watermark page that started up, and now I'm actually going to go and open my open report. Let's browse the first data set. So this should hopefully not take too long. So again, this is more just how we look at the data, how do we get it smaller. There's not much visuals, much DAX involved in this kind of example. So if I now go through to transform data, of course it's going to open up on another screen, but that's alright. Here you can see my sample data. So what I have in this sample data is I've got a store key, a product key, I've got the day marker or the date, and what I have is I have sales amounts that are converted to euros, to pounds, and to USD. Now the challenge here is when you start using currency conversions, you'll see you get a whole lot of decimal points that are added to the end, and these are actually quite critical. If you Again, got dataset, got hundreds of millions of rows, the decimal points start to add up. So I've got to be really cognizant of the fact that the values must still add up to actually do that. So just in order to show you what this now actually looks like, is I'm going to open up DAX Studio, and while that's opening up, one of the things that Power BI is really smart at is it actually will store all of these as integer 64 numbers, and what it does, it just remembers where the decimal point is in that place, and it you know, it's just one of the ways they're trying to make things smarter and smaller for that. So let me so what I can now do is, if I just minimize this one, I can go on my external tools and click on DAX Studio to open it up. Here I have DAX Studio, and one of the awesome things in DAX Studio is if you click on advanced, you've got this option for view metrics, which makes it so much easier. I actually use this a lot when I'm optimizing a data set to see what is consuming my data, why is it taking so much space. So the first thing I typically do is, if you have a look here under summary, you can see how much memory is this data set consuming. So as I can see over here, it's using 18.92 megs. While it doesn't sound like a lot, when you add 100 million rows, that could be in 10 gigs, 20 gigs, 80 gigs, etc. So it's currently using 18 megs of memory. So we could say that could be using 18 gigs of memory, for example. The interesting thing here is if you click on tables, and I just expand this, what we can now see is the cardinality. So we can see, geez, these are all, out of 134,000 rows, they're all pretty much unique. And the interesting thing here is, what we're always interested in is, what is the column size? How much memory is being used by these columns? So you can see over here, they're pretty much using 6 megs each. It could be 6 gigs. And the percentage table, they're actually using 32%. So they're almost using 90% of this table is being consumed by these 3 columns. And as you can see over here, the data type is double and the encoding is hash, which doesn't really make too much. But one of the interesting things here is, if you see this dictionary size, because when you have a high cardinality column, typically your dictionary size is pretty big, because it has to keep the dictionary, which is almost like an A to Z, of each and every single value, so that it can compute that. So as you can see over here, the dictionary size it takes up the majority of the space on the actual column size, because it's got to store all those dictionary sizes. So that's really interesting. And the other thing I'd like to show is, let me just find it over here. If I quickly drag this across, you can now see, and again, this is an example, is the PBIX file size is really good at compressing that into the PBIX, which is only using pretty much 5 megs of data. But when you open up a PBIX, it actually has to expand that into memory, and that's typically my thumbsuck roundabout way of looking at this, is pretty much 3 to 4 times the size. So if I take 15 multiplied by 3, 5 multiplied by 3 is about 15-ish, and as shown over here, it fits within that 3 to 5. So it's currently using 18 megs of memory. So by default, what you can do is you can say, okay, if my PBIX is whatever size, 10 megs, it's going to be 30 to 40 megs of memory that it's actually going to consume. So this becomes important when you're moving to data sets or limitations in terms of how much memory do you have to utilize. Again, like here, a small data set, you can get away with almost anything. Massive data set, where you're trying to limit memory and make things fast, this becomes a much bigger concern with regards to that. Cool. So now what I'm going to do is I'm going to take the same data set here. So when I was looking at this, I was going, right, how can I make this smaller, and what ways can I do to make that smaller? currently this is stored as a decimal number, which you could see in DAX Studio, which was stored as the data type of double. And I looked at this and I thought, okay, now what happens if I had to take this and just transform these three data types from a decimal number under the transform movement into a fixed decimal number. So what I'm going to do, I'll say add new step. So now you can see with a fixed decimal number, it's taken out some of those decimal points. The interesting thing is when you click on it in here initially, the fixed decimal number actually keeps 4 decimal places. So if you can see all of them, even though they're only representing 2, they're actually storing 4. So if I now take this, I click close and apply. There we go. Let's build that in. So now it's going to query that from my sample spreadsheet and load that into my actual PBIX. So what I now want to do is, and I'm just going to go and save this, and I'm just going to save this as 2 as fixed decimal number, just so that I have the differences with regards to that. What you'll now see is straight away, without me going into DAX Studio at the moment, I can already see that, oh, the file size has got smaller. Well, that's a good sign. Smaller file size means potentially if I take my 3 to 5, I should hopefully see a difference. And sometimes when I get to this step and I've looked at this on small data sets, sometimes it works, sometimes it doesn't. So I'm just going to close this DAX Studio down. I'm going to go in here and I'm going to open it up again. Awesome, so that's connected over there. And now when I have a look, I'm going to go and click on advanced. I'm going to click on view metrics. This is going to run again. And the first thing I like to look at is the summary. So as you can see over here, it's got a tiny bit smaller. It's gone from 18.41 to, well, from 18.92 to 18.41. So let me actually do this because it'll be much better just to see this as it goes along. I'm just going to open up the original one quickly with the awesome new Power BI logo coming up. It's nice when things change slightly, even though it does look similar but not the same to a Google Analytics. Okay, it's opened up on my other screen. Just bring it across here. Right, that one's open. Let me open up another instance of DAX Studio. Not sure what that area is. Let's see if we can. So there we go. So now if I have to switch between this one and that one, you can see that they are slightly different. And the reason for the one being smaller, again, is I go into the tables, I click on data, and now what I can see is this is the cardinality has dropped slightly, the column sizes have dropped, and the dictionary sizes have dropped. If I go back to here and I compare this one, you can see while it's not a lot, it's like 6.3, 6.3, 6.3, 5.1, 5.1. Over here it's 6.5, and that's so. And over here the data type is double, and over here the data type has changed to decimal. So once again, you know, if this was the first step, I thought, oh, that's cool. Let me have a look at that. And that's when, oh, okay, I've got like a 10 to 15% saving. That's pretty cool. But I still wasn't satisfied. I was like, there's got to be maybe there's a better way. It would be awesome if I could, you know, just get it even smaller than that. So I was like, oh, I wonder, I was thinking, and you know, I was like, they talk about how in Power BI where they actually store, if I just had to go back over here, let's open up this one, and over here, where they actually, this gets stored almost like as a whole number with a decimal point. And that got me thinking, and I thought, What happens if I could split these and then bring them back together? And what I mean by that is, what happens if I could split them so that they're now two whole number columns? And then because they're whole number columns, would that reduce the cardinality? And then in my DAX measure, because DAX is super fast, as we all know, can I bring those measures back together and get those looking the same? So I was looking, I was like, oh, let's bring in some sample data. Let's see if we can actually get it done. So that got me thinking. I thought, okay, let's see if I can do that. One of the challenges is when there's a negative here, I would still need that to be represented as a negative. So in this example today, I'm not going to go into the details of how I exactly did that, but it's just otherwise what would happen, and you'll see when I make the next change, is that while this -1 would remain negative, that 31 cents would remain positive. Now that's where, when you start looking and you're validating your data, which I suggest you always do to make sure it always matches, you're going to get the numbers different, and that's where those differences will actually pop in. So in order to do that, what I'm going to show you is, in my example, I actually did it at the source, but again, as we can do that in Power Query. So what I did over here, what I'm going to do here is I'm going to go first, let's just save this, save as, and now what I'm going to do is I'm going to save this as 3 as a whole number, just so we know which one's which, and that's saved as 3. Awesome. So in order to split the columns in Power Query, you can't split a fixed decimal or whatever. There's no actual option in here to actually do that. So I'm just going to change the data types here so they're all back to any. What that then allows me to do is I can go in here and I can go, where is it? Sorry, I want to click in the actual column, cancel that. No, I'll eventually get there. Oh, apologies for that. What I've actually got to do, I've got to change them to text. So let me go over here, change them to text. Now you can see, whoa, look at all those actual decimal points that are actually in there. So what I now will do is I'm going to right click and go transform. No, not transform, split column bar. I'll get there eventually. And I'm just going to say split it because I want the decimal point. So just find the first one, there only should be one. And now what I get is I get this. So what I'm going to now do is, what I did is I'm just going to rename that. Let's just get rid of that one. So that one will be cells here over here. I'm just going to rename them because it'll make it easier for our steps later on. And if I go back here and I change that to cents, you can now see I've got these two. I've got the whole numbers and I've got that one there. And obviously the change type is going to break, but that's okay. It just allows me, when I'm bringing the data set back together, to do that. And while I could add another step to rename this, I find it's just the less steps there are, again, the quicker Power Query runs, it all flows through, and we just start getting things a lot quicker. So I'm just going to go over here and do the same thing for the sales amount for the pound. Let's just get rid of that one, and let's go back here for the pound. Okay, and again, funny game sometimes with Power Query, where it very often is very helpful, but sometimes you don't want it to be all that helpful. And then the last one, let's split the US dollar. So let's do that and go back here, change this one to USD and go back here. Oh, sorry, getting lazy. Instead of doing the code, let's do it there. And the last time, and change it to cents there. So now you can see that I have those all running there, and what you can now see is that I've actually got all these different values here. So I think one step which I forgot was to yes, what I'm actually going to do over here, I'm actually going to go back here, and I'm actually going to transform these to a fixed decimal number, put that in, and what it is because I don't, the 4 decimal points is good enough, and then I'm going to change it to text. And the reason for that is because before I had that, those numbers were just so long, they, when you resum them up, they're actually not going to be of any actual value. So as you can see over here now, is I have got my whole amount and I've got my cents amount. The great thing is all these columns are now whole number columns. So one of the things, if I wanted to do, as you can see over here, that's negative. So that should be negative, is I could add another column, go through and change that to be negative for the actual cent column, or you could do it in DAX. Obviously I would suggest doing it in Power Query. So if I just said to take the sales amount euro cents, what I would actually do is just go add column, and actually what I would do is, I think it is, I duplicate this column and then I go scientific, no, one of them would be where basically I just find out if it's a positive or negative number, and then I would actually just go through. I'm not actually just going to go through it today, just for time. I want to make sure I leave enough time at the end of the presentation for questions. But it's just an extra step so that we can make sure we get those numbers together. But as shown, you can now see we now have got our 2 separate columns in here. And I know some people might be thinking, but a lot of the time you say, oh, reduce columns, keep things as small as possible. And over here, I'm now going through and I'm making more columns. Isn't that kind of, you're going against maybe what I said earlier. In some instances, in this example, by doing this, I'm actually making it the data set size smaller. So yes, while there are more columns, the report consumer will never see these columns. They're going to be hidden, and it's just going to work that much better. So now what I'm going to do is I'm going to click close and apply, and let's let that go. It shouldn't take too long to go through. There we go, same data set. We can see we put in there, yes, we have more columns. And what I'm now going to do is I'm going to save that, and if it all works as I have practiced, we can now see awesome. So that data set size now, just the actual PBIX, has dropped to 2 megs. So it's literally it's less than half the original size. Once again, let's go through to our good old DAX Studio. We'll open up the third copy. I'm not sure why that's coming up, but it does connect. Let's go to advanced, view metrics. Now this pops up, and again I'll go through to summary, and now I can see, oh wow, I'm only using 5 megs of memory for this. So that is taking it from 18 or 19 megs, it's down to actually only 5 megs. So that's, it's a massive saving. If that was originally 18 gigs, it's now using 5 gigs, which makes a really big difference when you're working on larger data sets, which I'm fortunate enough to be working on. Again, let's go into the tables. Now this is where we'll see the biggest difference. If I change the cardinality over here, what you can now see is this cardinality has changed significantly. It's a lot lower, the column size is a lot lower. The biggest thing here is the dictionary size has almost dropped to nothing. The data size is still there, and the now the encoding has changed to value, and they're all in 64. So if I compare this one, you can see over here the total column size would say 6 megs. The data size is almost identical, but the dictionary size before that was consuming most of it. If I go over here, these ones are now just 120 bytes. So it's really, really small. So yes, while there are more columns being used here, the overall is actually significantly smaller. As you can see over here, now from our previous one, where these columns were consuming almost 90% of the model, if we have a look over here, the product key, which is actually a string, is too big. So what I could do, just because this will have the better of me, is these we know are not strings. This is the date. So if I go back to my data set over here, number 3, and I'll go to transform. Let's just go over here. So we know that these two are actually also whole numbers. So again, change that to a whole number, and let's change this to a date. So now, okay, I've got date and keys, which makes me really happy. So let's just go and save that. Especially applying that. Save it again. I have a look. So the file size hasn't actually changed too much. And in DAX Studio, we got the 5 megs. If I now refresh that, fortunately it's nice and quick, small. I've now got that smaller again. I got it down from 5 megs to 2 megs. So again, another significant saving by just checking the data types, making sure they're not all set to string. And if I go back to my table, I can now see, oh, these columns are consuming the most space, but they're tiny. I mean, you know, the actual amount of space here is like, it's not even 1 meg of memory that it's consuming. Where if you compare it to the first one, these columns were consuming 6 megs, 6 megs, 6 megs each. And now we actually, you know, the whole model now in its totality is consuming less memory than one of the original columns consumed. And that, to me, that's awesome. That makes a huge difference. You know, it makes it a lot easier, things a lot quicker, and easier to use, which is really cool. So one of the ways is just to show you for completeness is, okay, that's great. Now I've split these columns. How do I bring this data back together so that the sum will be correct? And as I've said before, I'd have to factor in for the negative sense, which I haven't done in this example, but it's one of those things you can definitely do. So if I just take my measure I have over here and I'll go new measure, I'll paste it in there, and I just go over here so it's easier to see. What I'm now doing over here is I'm saying get the sum for the whole number and then add it to the, if I just work in here, the cents column, but divided it by 10,000. Because I had those 4 decimal points, I want to bring it back in line, so I just have to divide it by that same amount. So if I click on that and I have spelt it correctly, etc., now I have my sales amount and I can bring that in, and as you can see, that's ported in and it's nice and quick, you know, and there's the actual value. So if I say sales by day, there we go, you know, it's ported in, it's nice and quick. The end user, typically all of these will be hidden from the end users, so they won't see those actual values. They can just see, oh, the sales amount that I have in there, and it just works, and it's really a lot smaller, which is really cool. And I think this can really help for users using large data sets. How can I actually make these smaller? So once again, I've taken it literally from a 18 meg file, which could be 18 gigs. I've actually reduced it down to 2 gigs by just looking at these data types and seeing what I can do to make those smaller, and using DAX Studio, which is really awesome with the view metrics, makes it quick and easy to get that information and understand what's going on in my model, where's memory being consumed. And one of the other things in here, can't see today's no relationship, is just a little side, is under relationships, if you've got it, is this missing keys and invalid rows. This is really handy for when you're looking, you're like going, does all data set match? Is it all good? This can just very quickly help identify why the key's missing, and start you investigating what's going on there. Awesome. So if we have to go back to the PowerPoint presentation, moving on from there, just a quick recap. Smaller is better. The smaller I can make it, the better, as I did there by taking the data set from a decimal number to fixed decimal number to a whole number, and then as I did in the end, I forgot to change those strings, and making it literally as small as possible. Second to that is using the star schema. The star schema, it's the way the engine's designed. It's really fast, makes things easy for the users to understand, easy to work with. Smaller is better. And then finally on the right hand side is the dimension and how they work when you start using DAX and filtering data through with regards to that. Moving on from there, my actual real world implementation where I actually did this, I had a data set that had just over 1 billion rows. That's actually grown now to 1.5 billion rows. And what I did was so a saving of 60%, you go, what did that equate to? So the model was previously sitting at about 90 gigs. So I was using Azure Analysis Services. I had to go up a whole SKU because with 90 gigs of memory, I don't have enough space to process large tables and or DAX queries that sometimes spill over and need more memory. It used to take almost 2 days to process if I had to do a full cube process, which is really cumbersome. You got to let it process overnight, you go to bed, you hope it's running in the morning. And by putting in these best practices and changing the column data types, I actually reduced it down to 37 gigs. So that was a massive saving. I could then go down Analysis Services SKU, which data set smaller, save money, it's faster. There's just win across the board with regards to that. And then on top of that, I implemented from full CMark the approximate distinct count, because we have a lot of distinct customers, and that just made the whole model even faster. And when I tell people, oh yeah, the model's it's pretty big, they see the performance and they're like, wow, I didn't understand that it could run that fast with that much data, and you've still got this full Power BI interactivity, which is really awesome. And people just use it, they love it. It's great to see and great to use. So special thanks once again to Microsoft for supporting the conference, and the Data Platform Geeks and the SQL Server Geeks for putting this together. I really appreciate it. It helps me and you. We all want to learn, we all want to find new things, and makes it really great. 3 ways to win prizes and say thank you. You can post a selfie with the hashtag DPS2020, give a session and conference feedback, which I'll put up on the next slide, and visit the sponsors and exhibitors, as well as follow the guys on Twitter, the Data Geeks and Data AI Summit. And once again, before we take any questions, here is the URL for the session evaluations. If you can please fill that in, it really helps not only the organizers but people like myself who present. Always like to see what am I doing right, what do people enjoy, what am I doing wrong, where can I improve, and just help people get a better experience. And as well as me, I'm learning, I'm always evolving, and just trying to get those going. So thanks, and we'll now go to the questions.